All right, hello everyone. My name is James. My middle name is Everett. That's what everyone calls me. And now people are starting to call me Metalsnake, which is my Discord handle. I'm not a professional in the cybersecurity industry. However, I do want to be one eventually. Anyways, I've built a program that is pretty interesting, and I think some of you will find it pretty cool. I call it Espio, which is short for espionage. Espio is an OCR triggered keylogger, which means when a window pops up on your screen and it contains a keyword, a phrase of interest, you get a screenshot sent to your C2 server, and then a keylogger is activated. First, I need to go over some background in order to provide some context to the whole of this presentation. First, I'll start with a quick lesson about keyloggers, then I'll actually show you the program I built. I'll show you it working, and then I'll elaborate on how it works. And I'd just like to say, I'm just going to run through this part very briefly because the context and the history of keyloggers I don't think is as interesting as the tool itself, and that's what y'all are really listening to this for. So anyway, I like to consider SPO an evolution on the timeline of keyloggers, but I don't think that means old keyloggers are bad out of date. This is an old IBM Selectric typewriter. In the 1970s, Soviets snuck hardware implants called Selectric bugs inside these machines. The bugs detect the mechanical movement of the type ball when a key was pressed, and every key press produced a distinct signature of mechanical motion. The Selectric bug captured that signature. It would then communicate keystroke information wirelessly via short radio burst in the 30 to 90 megahertz range. This frequency is overlapped with television bands, which may have helped the Soviets avoid detection. It took the NSA roughly 8 years to find these bugs and the typewriters at the US Embassy in Moscow. Yikes. Fast forward a few decades, now we have the ghost keylogger. This keylogger emerged in the early 2000s, and you can actually still buy it. It records keystrokes, the clipboard, browsing, messenger conversations, and then it dumps it into an encrypted log and emails it to you. The main problem with the Ghost Keylogger is that it does not have stealth that is up to snuff for modern systems. Now, there is a problem with the average keylogger. You might end up getting a file that looks like this. And, if you get this, you might end up feeling like this person. I hope not, but you might. Might feel like you're looking for a needle in the haystack. Here's just a quick diagram that I made to further prove my point. So here's another nice image. What if your keylogger had eyes? All right, so I'm just very quickly going to go over the antivirus settings, and I just want to show you that there's no exclusions. You can also see that the firewall is fully enabled. Next, I would just like to make a quick note about something. Currently, when Espio is executed, a command prompt window does pop up, but that can be removed. I just don't want to remove it right now since it's attached to a debugging function I have within the program since I'm still working on it. SPO isn't a finished program. This is still a prototype, but you can see here that it's working. Before I dive deep into Espio and talk about some of the techniques that I used to create it, I'd like to go over the dual mode architecture. Here we have passive mode, which is what Espio spends the majority of its time doing. It takes a screenshot every 1 to 2 seconds. OCR scans those screenshots. If no keyword is detected, it loops back and goes through passive mode again. If a keyword is detected, it goes into active mode. It sends the screenshot that triggered active mode to Discord. The keylogger is turned on. The buffer is exfiltrated to Discord, and active mode stays active for a set amount of time. Also, I just want to say that for the OCR functionality of Espio, there is a words list that OCR reads from. So you can change any of these words to change the parameters of the OCR trigger for the keylogger. So if there's something more specific that you want to add to it, you can do that. But right now, this is what I have it set to. Espio as a whole has been built to be as modular as possible. You've got different settings here, random delay, random interval between screen capture. Um, you got random delay before sending captured data to Discord. Um, a few things. How often to check the clipboard, although the clipboard function doesn't work right now. Anyways, you can limit the screenshots. There's a few things you can do. So now that we've talked about the high level stuff, I want to start getting into the technical details. Firstly, I want to talk about screen duplication. There are several native API options for Windows screen duplication. The primary ones that I am aware of are DXGI desktop duplication and GDI. For this program, I decided to use GDI. It's compatible with Windows all the way back to Windows XP. The API is simpler than DXGI. GDI also has a low dependency footprint. It's just GDI 32 DLL, which is already loaded in every process. However, there are some cons. It is slower than DXGI, especially for full screen capture. It still works fine in the videos you saw, but in slower machines or maybe some virtual machines, it might lag behind. And that also applies to multi-monitor setups, though I've only really tested this in virtual machines and on a laptop, an old laptop. Um, so I still need to do further testing to get accurate measurements. Anyways, GDI also doesn't capture hardware accelerated content well. Some DirectX/OpenGL apps might show up as black rectangles. This API is also CPU bound. So I really use GDI out of compatibility, stealth, and ease of use. I do want to talk about DXGI because it's a pretty strong alternative and it deserves to be talked about. DXGI desktop duplication captures frames directly from the GPU, which means lower CPU usage. It can capture hardware accelerated content that GDI misses. It's what OBS, Discord, Screen Share, and most modern capture tools use. There are some drawbacks though. It's only available on Windows 8 and onward. The API is also more complex. Now, DXGI duplication requires the process to hold a reference to the GPU output adapter, which means if EDR is monitoring direct 3D device creation from non-graphical processes, that's an instant red flag. You don't want a background process or an injected DLL suddenly creating a direct 3D 11 device and then calling acquire next frame. That's a distinctive behavioral signature, um, especially when compared to what GDI does. GDI calls get DC/bitblit, and hundreds of legitimate applications do that constantly for rendering UI elements. There is a problem with DXGI and GDI. Some applications use an API function called set window display affinity that blocks GDI, bitblit, and DXGI desktop duplication. You would get a black rectangle if you were to look at the captured frame. So the thought I've had is to create a fallback capture method which can bypass some set window display affinity setups. Um, that's a rabbit hole though, and honestly could be a separate talk probably. Also haven't really implemented that or gone down that rabbit hole yet. but I will look into it in the future. Now that we've talked about the screen capture method, I'd like to briefly talk about the OCR engine. Windows has a built-in OCR engine called the Windows Media OCR engine. You feed it a bitmap that you get from the screen capture method, and then it returns recognized text. It is native to Windows, so every Windows computer from Windows 8.1 and onward can utilize the OCR engine. Thank you, Microsoft. I'm really hoping for Windows 12 they add a passive OCR engine feature that's working 24/7 in the background to make the user experience even better. Anyways, I like the built-in Windows OCR engine because it blends in better. There are apps like the snipping tool, Microsoft Office apps also, OneNote in particular, and also like Windows Recall / Copilot. They all use the Windows OCR engine. You just got to think like anything that extracts information from the screen is going to have to use an OCR engine. So another thing that's very nice about the native OCR engine is that there are no additional dependencies. The OCR engine also automatically handles whatever language the target has configured, which is a really big deal. Tesseract, another OCR engine, would require you to bundle language data files for each language. I want to be adversarial with myself and to the audience listening from this and learning, because it's always important to be honest. There's something called URL triggered keylogging, which can be good because you can trigger keylogging based off of like active URLs, and that's basically way quieter than an OCR engine running with screen capture and all of that. But the reason you would want to use a OCR triggered keylogger like the one I have here is that sometimes you might not have solid recon information. You might be targeting non-browser apps, dynamic URLs, and scope changes. So, you know, that's why you might want an OCR credential harvester instead of something more traditional. So, I'd like to now get into how I actually did the keylogging. This is the first time I've worked with syscalls, so it's pretty interesting for me. Most keyloggers use an API function called getAsync keystate for logging keystrokes. The problem is that a lot of EDRs flag it. There are some workarounds though. GetAsync keystate doesn't actually check the keystate at a user mode level. It's a wrapper. What it is really doing is calling into user getAsync keystate in the win32u DLL, which then execute a syscall into the kernel. The kernel is where the actual keystate information lives. So getAsync keystate is just a user mode function which acts as the front door to get that syscall into the kernel. To get around that front door, the first thing you have to do is find what the wrapper function is actually calling to. And before I go any further, I really want to explain this quickly. I want to explain one reason that most EDR vendors usually hook functions at a high level. In this case, for getAsync keystate, which is in user 32 DLL, it's because those functions have the most stable API. It doesn't change between Windows updates, so hooks don't break, hopefully. If an EDR were to hook into Win32u DLL, they would have to constantly deal with compatibility because Microsoft can and will change the internals across builds. User 32 DLL is just more stable. However, some EDR vendors do hook at a Win32u DLL level though, so this isn't like a total workaround. I also need to quickly explain what a PEB is. PEB stands for Process Environment Block. It's a user mode Windows structure that holds important metadata about a running process, such as loaded DLLs. Every process has its own PEB. Anyways, now that you understand contextually and conceptually where I'm coming from, you will understand why I needed to make a syscall. First, I needed to find where Win32U-DLL is actually loaded. I used peb walking to do so. After doing that, I did something called PE export parsing. This tells you where in Win32U-DLL NT-user async key state is actually loaded. After that, you will finally have a syscall number, which can be used to call NT-user get async key state and get around that pesky front door that some EDRs hook. And that's not all. I'm not just going to stop at syscalls. I want to upgrade that by turning it into an indirect syscall. So once you finally have a syscall number, you have a problem. The return address in the call stack points to your RWX memory allocation, not a Microsoft DLL. A modern EDR does stack analysis. So instead of executing the syscall instruction in your memory, you find a syscall ret gadget that is already inside Win32U DLL. Then you jump to it. Now the return address of the syscall now points to a legitimate Microsoft module instead of your own RWX memory allocation. Also, just as a side note, I have an elite hacker friend, and he told me that as I get better, I'll not need to use syscalls/indirect syscalls. He didn't elaborate though. I think he's probably talking about exploit development. I'm not sure, but if anyone has any idea what he might be talking about, please let me know. For the C2 communication, Espio sends data to Discord webhooks using WinHTTP over HTTPS. The traffic goes out to discord.com on port 443, which looks like normal Discord traffic at the network level. However, endpoint detection will see that an unknown process is talking to discord.com. That's a red flag. Also, some network monitoring tools will see a process creating discord.com traffic from a process that is not discord.exe. Discord actively scans for webhook abuse. If a webhook is reported, or if Discord's automated system detects unusual patterns that kill the webhook URL, effectively making Espio useless. So Discord is definitely not the best or even a good C2 solution in my opinion. And honestly, creating a good C2 server/system is something that I'm looking forward to doing. There are still some problems with Espio though. Firstly, my indirect syscall stub is 21 bytes allocated with virtual allocation using page execute read write. That is well known by EDR heuristics. Legitimate applications almost never need memory that is simultaneously writable and executable. A lot of popular EDR products all monitor for private RWX allocations. Some even flag on the virtual location call itself. One workaround I was thinking of is that if I could make it so Espio masquerades or injects into a GIT process, its own RWX memory allocations blend in with the process's expected behavior. By the way, a JIT process is any process that compiles code at runtime rather than ahead of time. JIT process repeatedly allocates executable memory during normal operations because it is compiling code on the fly as the code is needed. Here's another major point of failure. The polling in this program is very, very aggressive. It pulls 80 plus keys in around 1 millisecond, which means there are around 80,000 syscalls per second during active mode. That's unusual behavior. Additionally, CPU usage spikes during the active window, which gives way to another detectable pattern. Alright, so now for the major point of failure. It's about optimization. This mainly affects slower computers and virtual machines. I personally haven't experienced it on my main desktop. However, there will always be a latency gap during the transition from passive to active mode, regardless of how good the computer is. That's unavoidable. It's just more noticeable on older and slower computers. When a keyword triggers active mode, Espio doesn't instantly start logging keystroke. It has to do several things first. First, when OCR detects a trigger word, it has to send that screenshot to Discord, but the image is just a raw bitmap. Discord doesn't accept those, so it has to be JPEG encoded. Next, Espio's mode flag is set to active mode. When the JPEG is sent to Discord, polling begins. The buffer is exfiltrated to Discord after a set amount of time. So basically, because Espio is single-threaded, the keylogger can't start polling until the Discord upload is complete and the main loop cycles back to active mode. The reason it has to cycle back to active mode is because when the JPEG is sent to Discord, the loop is still technically in passive mode. One thread can only do either passive or active mode work. The thread has to finish its current work, loop back, read the set flag, and then act on it. When the Windows operating system is utilizing Copilot/Recall, it's already doing periodic screen capture and OCR because Microsoft wants you to be able to search or recall what you were doing. So speculation leads me to believe that Microsoft might be working on releasing a more consistent passive OCR feature for the Windows operating system in the near future. This would make the passive mode of Espio harder to detect because it would begin to look more like a Windows feature rather than malware. However, Microsoft has restricted recall in the sense that you have to opt in to use it. And I've also read that Microsoft is considering and/or is working on reworking recall, so it could potentially be removed in the near future. I have no idea though. However, I don't think the overall trend towards operating system level machine learning / screen understanding is reversing.